this is number 33 from section 7.6, which I do think is one of the tougher problems in this section. Now, you may have done it a different way than I did, and you may have gotten a correct answer, but here's a way that'll work. So I originally looked at this and I thought, oh, I could break this up as two fractions over a common denominator. I could have 1 over sine and a sine over sine, which would end up equaling 1. And it just didn't seem to match up real well with the cotangent squared on the other side or that kind of thing. So I ended up not doing that. I decided to tackle this side over here, and I said, okay, cotangent is the same thing as cosine over sine. And so it's cosine over sine being squared, basically. And so we're going to break it up that way. So I'm going to do 1 plus sine of theta over sine of theta. And I'm going to basically break this out. I'm going to write this as 1 over cosecant of theta minus 1 times cotangent squared of theta. But in place of the cotangent squared of theta, that's the same thing as cosine of theta over sine of theta squared, both the numerator and denominator being squared. So I'm going to set it up kind of like this. And specifically, I noticed something. Cosecant is 1 over sine. And I noticed that I would get some cancellation, some simplification when I multiplied this out, okay? So in the next step, I'm going to multiply this denominator by this and the numerator by that, and we're going to end up with 1 plus sine of theta over sine of theta is equal to cosine squared of theta over, now, sine squared times 1 over sine would give you sine squared over sine, which just simplifies down to sine of theta. Sine squared of theta minus 1, that would be sine squared of theta, okay? Now I see a whole lot of sines over here, and there are a whole lot of sines over here, and we have this cosine. So I'm thinking, well, maybe if I can get it down to all sines. Remember, you've got the Pythagorean identity. Sine squared of theta plus cosine squared of theta is equal to 1, which means if you subtract sine squared from both sides, cosine squared of theta is equal to 1 minus sine squared of theta, okay? So I'm going to replace that with 1 minus sine squared of theta. So 1 plus sine of theta over sine of theta is going to be equal to 1 minus sine squared of theta over sine of theta minus sine squared of theta, okay? And if you notice, the numerator and denominator kind of look the same, but not quite. And then I realized something, oh, I could factor a sine out of both of these. If I factor a sine out of both of these, I'm going to get sine of theta out in front, 1 minus sine of theta inside parentheses. Okay? Well, you may be thinking, well, what difference does that make? Well, hang on. So I've got 1 plus sine of theta all over sine of theta is equal to, this is a difference of squares. Okay? 1 is a perfect square. 1 times 1 is 1. Sine of theta times sine of theta is sine squared of theta. That can factor as 1 plus sine of theta times 1 minus sine of theta, okay? And if you notice, that would give me the same thing that I have in the denominator here. So I'm going to do that factorization. 1 plus sine of theta and 1 minus sine of theta. It's pretty common, if you get a 1 minus sine squared or 1 minus cosine, pretty common strategy in a lot of these problems. And what this is going to enable you to do, I've got a 1 minus sine of theta in the top that I can divide out. I've got a 1 plus sine of theta that I can divide out. I can divide out a 1 minus sine of theta, or I can divide out a sine of theta. The only one that I can divide out of both the numerator and denominator is the 1 minus sine of theta. Anything divided by itself is equal to 1, and we're just left with this equaling itself. Technically, you should do one final line and make the conclusion 1 plus sine of theta over sine of theta is equal to 1 plus sine of theta over sine of theta. But that's all you need to do. So tough problem. And if you didn't see that, the couple of those factoring cases, it really makes a big difference.